class we're going to look at how images are digitized. It's possible to scan a print or a negative of a photograph. It's also possible to make a digital image directly using a digital camera. Either way, the process is largely the same, and we have largely the same concerns and issues. Now, for simplicity, we're only going to consider black and white images for the time being. So that's images with just black and white and shades of grey. No colour as such, like red, green and blue and yellow. Now, let's have a look at this image here. This is some sort of fishing hut near a beach in Italy, as it happens. So let's imagine that this was an old-fashioned photographic print that we wanted to digitize. In the first stage of the digitization process, the image is divided up into non-overlapping rectangles. Now, very often these rectangles are actually squares. It's not uncommon for the rectangles to be wider than they are taller, but it would be unusual for them to be taller than they are wider. But more often than not, they're actually squares. So for the next stage of the process, the digitizer zooms in and examines each individual square separately. And then the process works out the average darkness of the contents of the square. Now here we see a scale from black to white broken up into ranges. And inside in these are various shades of grey. So now the computer has to decide which range the average darkness of the square falls into. This one here is very dark, and you can see it falls into the bottom range. This area here is lighter, but it's not quite white, and it falls into this range. The digital representation of the image is made up of pixels. A pixel is a small rectangle with just one colour. That colour is representative of the quantization level, or the range of levels, that contains the average colour of the corresponding area of the original image. So each pixel stands in for part of the original image. And that pixel's colour is the average colour of the contents of the area it's standing in for. To make the digital image then, the code representing the colour of each pixel is stored. Pixels are usually stored from left to right and top to bottom, in the same order that English text is read. More quantization levels will mean more distinct pixel colours, and so more subtle gradations of colour. Of course, more quantization levels means more bits. Typically 8 bits per pixel, or 250 different shades of grey, is plenty for a black and white image. Often less will do. If fewer quantization levels are used, the digital representation of the photograph will be less accurate. Look at the effects here of reducing the number of quantization levels. The number of levels, or bits per pixel, is sometimes called the pixel depth. This can be expressed as a number of colours or as a number of bits. A high quality black and white image would likely use 8 bits per pixel, or 256 shades of grey. Sometimes fewer bits per pixel are used in an effort to keep file sizes small. Now let's go back to the start of the process where the image is divided up into rectangles. If the size of these rectangles is small, then the total number of rectangles will be large. This will result in a large number of pixels in the digital representation. The more pixels there are, the more accurate the digital representation will be. The number of pixels per unit of distance is of course the sample rate. We saw this in earlier classes when we were talking about the temperature being measured over time. For images, the sample rate is usually measured in dots per inch, or dpi. Dots per inch is even used in parts of the world like Ireland, where metric units would ordinarily be used. An image digitized at 100 dots per inch would have 100 pixels per inch of the original photograph. But a photograph is a two-dimensional object, so a square inch of the photograph would be 100 pixels across and 100 pixels down. That means a square inch of the image would require 10,000 pixels. This squaring of values can sometimes cause confusion. Try to think of pixels as coloured tiles in a very large mosaic. The number of tiles needed depends on the width and height. When an image is stored digitally, all that's recorded is the colour of each pixel. The pixels themselves don't have any size. Now, this can sometimes cause confusion when preparing an image for display on a screen or for printing. A typical computer might display pixels on the screen at a density of 70 to 100 dots per inch. 72 dots per inch is very common. An image 800 pixels wide might fill the bulk of the screen. However, if you printed a digital image with 100 dots per inch on paper, it would be considered to be poor quality. Images printed on paper typically need a resolution of about 400 dots per inch to look good. This is why images taken from websites often don't look very well when printed. When there are too few pixels for the space where they are displayed, the individual pixels need to be relatively large. This often results in very noticeable pixelization. When working with digital images, we need to remember to capture in high resolution, work in high resolution, and then deliver the appropriate resolution for the final display. In general, it's a good idea to capture digital images with as high a resolution as is practical. So you should use a high resolution setting for your scanner and the highest quality setting on your digital camera. From that point on then, any editing should be done at high resolution. It's only at the very end of the process should a low resolution version of the image be produced. So if an image is going to be used on a web page and it's only going to say be 300 pixels by 400 pixels, if that image came out of a digital camera at 4000 pixels by 3000 pixels, you should edit it and work with it at that high resolution. And then only when the image is exactly the way you want it, should you resize it to 400 pixels by 300 pixels for display on the page. So capture all your images at high resolution and work with them at high resolution. And then only when you're finished working on them, reduce to the appropriate resolution for the display, whether it's going to be displayed on the screen or sent to a printer for printing onto paper. Try to remember that pixels have no physical size. Pixels will shrink or expand in size to fill the area they're displayed in. When digitizing an image, the main task is to ensure that there are enough pixels to produce a fair representation of the original image when the pixels are displayed. So there are two main factors affecting the quality of a digital image. There's the number of quantization levels that we use when assigning a colour to the area that the pixel represents, and that's sometimes known as the pixel depth and can be measured as the number of bits per pixel or the number of different colours. The second factor affecting the quality of the digital image is the number of pixels. The more pixels you have, the better the quality of the digital image will be. So a given image will have a number of bits per pixel and will also have a number of pixels. The more bits per pixel you have, the better the quality of the image, and the more pixels you have, the better the quality of the image. Just how many pixels you need will depend on how large the image is going to be displayed. If it's going to be displayed inside in a browser on a small screen, you'll need fewer pixels than if it's going to be displayed on the side of the county hall. So as before, we have the number of bits per sample and the sample rate. And so both of these factors will affect the fidelity of the digital representation.